Hello everyone, welcome to the third session of the end-to-end training campaign. In today's video, actually, we are going to cover these three main points, which is related to the end-to-end call flow and signaling content. But we'll try first to recap the VoLTE protocols and the SIP description general, just to have high-level introduction and high-level understanding about it before digging into the details of the end-to-end signal. Then we'll be ending by going through the contents of the end-to-end call flow. We'll go through as much as we can and explain the contents of the messages to make it more clear for you about how to do the troubleshooting and analysis if you understand the signal contents. I suggest if you didn't watch the previous two sessions to go and watch them first before watching this one because it will make it more easy for you and it will facilitate your understanding. So let's move forward for the next slide. So actually, initially, I would like to start with you about the VoLTE protocols and the interfaces as well. First of all, that in VoLTE there is two main protocols. This is two main, or they call it the core signaling protocols used usually in IMS, which is actually the diameter protocol and the SIP protocol. The SIP, the diameter in general is using to, as mentioned, need to authenticate or authorize or even provide accurate billing information. And as you can see, diameter is usually between, for example, the HSS and the serving CCF or the MS in general here. And here is, for example, every time the SCF required to get some information about the user, he will go and inquiry the HSS. And even though the between the HSS, for example, and the other entities in the ABC, this is also using diameter protocol. And also it's being used between the BCS and the BCRF. And this is like in case the BCCF would like to do provisioning for the quality of service and so on. So it will query or request the BCRF to start. So this is the protocol used, which is called diameter protocol. And for the SIP protocol, it's just used to establish and control the real-time data. For example, if you'd like to have signaling messages and to start establishing all the SIP signaling until you get the dedicated bearer activated. So this should be done through the SIP protocol, which is actually abbreviation for or stands for Session Initiation Protocol. And also there is a very important one, which will be covered today in details. It's called SDB. This is called Session Description Protocol. And this is usually you'll find it within the SIP invite message. Within the SIP invite, you will find two parts actually. The first one, which is called SIP part, which is including the signaling, and you'll find something called SDB, which is Session Descriptor Protocol or Session Description Protocol. And this is just include information about two pieces of information, which is the first one about the media type. For example, this is going to be a video call or a voice call. This is one of the information. And the other one, it's about the codecs supported by the users. For example, in the same invite, they call it SDB offer. For example, the MO users will be sending the SDB offer for the MT users, telling him, this is my supported codecs. I'm waiting for your response with SDB answer. So later on, the MT users or the terminating users, you need to send back SDB as well, but it will call SDB answer. Also, it will be including the supported codecs. Then you will start negotiating until they reach into a common codecs between both of them. And the last protocol is called real-time protocol, and this is usually used to carry the traffic, which is media, and this is usually carried all through the dedicated bearer. And there is one protocol also between interface and the protocol between the users and the MTAS directly. It's called UT interface, and it's using a protocol called XCAP, and just this is using for the supplementary services as mentioned here. And if you'd like to get more details, you can just refer to the HBB about this point. So now let's move forward for the next part. So now let's go through the second part, which is related to the SIP messages. Actually, then the SIP messages, I will try to go through the high-level description or high-level introduction about the SIP messages before we jump into the end-to-end call flow. Actually, SIP messages, we can classify it into two parts. First one is called the SIP request, and the second called SIP responses. And this SIP responses is classified or categorized into two things, which is the provisional and final. Provisional means that sometimes that you would like, for example, to do provisioning or inform the other side of the call that, for example, I would like to, this is my codecs and I'm waiting your confirmation, or or you're alerting, for example, through 180 ringing. So this means all the time you will be waiting for a response, which is called final response. So provisional means that all the time it must be acknowledged by something, right? Which is the step response, even successful, which is the 200 plus, or for example, the other steps, which is from 300 till 600. So now let's go quickly through the main messages, which is actually will be more explained in today's session. So let's, for example, go through the first one, which is the register. We already explained about this part in the previous session in details for the end-to-end call flow about the register. Register in general, it's being sent by the client or the user in general, just to requesting to, I would like to register to the SCCF, right? Or the IMS in general. He would like to register to the SCCF to start, for example, sending the same invites and start making the calls in general. And the same invite, it will be sending from the mobile originating or the client whenever he would like to invite another user to start a call, or he would like to call another user. So he'll be sending SEP invite. Actually, the SEP acknowledgement or the acknowledgement, this is usually comes at the very end of the call and in the context of the SEP invite from the client or the mobile originating. Whenever he's acknowledging, yes, now I can, after he received the 200 okay, after 100 ringing, just sending acknowledgement, yes, now I can start the call. So this is the last final message, and we'll be discussing this in details. And the highlighted, two highlighted, this is also very important. The SIB update, this is actually usually sent by the mobile originating device. This is whenever you have this kind of things called precondition. We'll be discussing about this precondition, but in summary, preconditions means that the terminating users cannot send 180 ringing until he receive a confirmation from the mobile originating call that he has already established his media or his dedicated bearer. So this is information will be sent through the mobile originating through the update message, and this is just indicate that the preconditions has been accepted and the media is now active for the mobile originating call. This is what it means by the update message actually. The BRAC actually, this is called BRAC 183 because this is usually a response for this message was called 183 session progress. And this is message usually sent by the mobile terminating call, which is include the SDB answer or SDBS answer from the B side, which is telling the mobile originating. This is my supported codec ranges. So it's being sent in this within this message. So this is like acknowledgement from mobile originating for this particular message. Actually, this is the main message highlighted here, which we discussed today, but let me quickly scan these three messages as well. This is by message actually in case, for example, the users already won't like to end the call. So this by message will being sent. And usually the by message can be also during any failures and usually cover the cause. For example, if the user is initiating the call, it will be showing as showing here. For example, that this is user triggered, the user triggered to cancel or to end the call, sorry, to end the session, and he would like to clear the session. So it will be sent as save message, save by, so it will be save called user triggered as a reason. And the second one, it's about the save cancel. Actually, this is in case, for example, assume that the user already initiated save invite, but before it's being responded or before it's being receiving response from the mobile terminating, he would like to cancel the call. So he will send cancel the call. So this save cancel will be sent at the end. And now let's go quickly through the provisional messages as well. For example, this 100 trying, this is just usually sent by the server to, for example, if the user sends 7 invite, it will be responded by 100 trying, telling him, please don't send a new request. I already received your request and I already started the provisioning and I will get back to you soon. And 180 ringing is usually sent by the mobile terminating to alert the originating or the mobile originating call, mobile originating terminal that I already now start ringing. And 183 session progress we already discussed. This you usually send by bulk terminating includes something called SDP answer, which is including the codecs supported date. And quickly for that part, any 200 messages, this is means it's the message is being successful. For example, 200 OK, 200 OK 7 byte. This means your request is being acknowledged and successful. And this is, for example, 300 redirection or redirect. This is usually when the mobile originating sent to a wrong server, or let's say that this is not his server. So the server, for example, server 1 and server 2, so server 1 know that this request should go to the server 2, so it will reply back to him, you should be redirected to the server 2, and so on. And you have this 500 server failures. This is indicating that there is a failures. For example, there is something called 504 and 503 server internal error or and so on. This is indicating that there is a problem in the server. So this is like a response from them, and there is 600 failures. This is indicating there is a global failure that many terminals is facing the same issue. And this is also 400, including the explaining that there is a problem in the client. For example, client mistake. For example, let's say assume there is one common one which is called 486 busy here, which means that the terminal is busy and he cannot pick the call. So this will be sent for that for the mobile originating call from mobile terminal or from the IMS to the mobile terminal, which means in like 486 means that the user I'm calling is currently busy. So now let's move through the end-to-end call because this will take some time. Before I go to the end-to-end call flow, which is including both RAN and the EBC plus the 7 byte, I would like just to explore first the end-to-end SEP signaling because this is like to make it more clear for you. Usually, you will see most of the messages or the explanation between the UE and the proxy, and this is also fine. But I would like to take the complete flow just to explain what's happening. So the first thing the user will usually do, he will send the 7 byte message, and this 7 byte contains two important information. It will be sent first from the mobile originating to the proxy CSCF, which is acting as a first point of contact. This is including two very important information, which is having the first of all the media type, which is for example indicating that I'm doing a voice call, not a for example video, and also my codecs is XYZ, for example, and this is called SDB offer. My SDB offer is voice call plus this is my codec type. Then it will including some information, for example, the IP and the phone numbers from the originator terminating, just to get some information from proxy, which device I'm going to call, and what is my IP whenever you are going to send back a response to me. So directly the server or the BCSCF will reply 100 trying, and this is the main cause of that part, that just sending that, please don't save any save invite. I already received your request and I start already progressing your request. So don't send any new sub invite until I get back to you. Then the same message will start be forwarding to first part to the SCCF of the mobile originating. And as you know, during the registration already the serving DSCF already known by the user and the proxy, so it will be directly send this part. But the first thing the SCCF would like to do, it just would like to confirm first this user is capable to make originating calls or not. For example, there is no any restriction, he's not barred, he didn't finish his credit, and so on. So it will go and query or invoke the MTAS, as you can see here. It will prompt the MTAS for generating service to confirm that the user is capable or not. And for sure, every 7 byte will be responded with 100 trying. And the main cause again, that reason for 100 trying, that to tell them, guys, please don't send new 7 byte. I already received your request. So now that will prompt it. Once it's being confirmed, the SCF will go and query the enum, as you can see here, and it will have please query the enum, please find the user p location or domain name. I cannot find, this is the information for the user, please translate it or resolve the number into domain name or the example IP address, which is including the DNS also might be a part of this process. So this is a main function, and we already discussed this in the previous session. Once he got the information about the user B location or the terminating, now the SCF will be communicating, will sending the same invite message to the interrogating SCF for the terminating. And as we mentioned, SCF is acting as a first point of contact for the incoming calls. So it will be the first point of contact, and this is opposite to the proxy for the originating acting as the first point of contact. So now the same invite message will be forwarded from the SCCF to interrogating CSCF after the enum told them the IP address or the location of this particular user. So 7 byte will be going again, 100 trying will be coming back, but the ICSCF now doesn't know this user is served by which serving CSCF. So now the ICSF will need to query about the information which is being shared here for this user information from the HSS to ask him this user is served by which CSF. Might be the network having different SCSF serving CSCSF, for example, 4 or 5 or whatever. So it will be sending check, please tell me which one is being serving this particular user. So it will tell him, for example, SCSF number 2 is serving this particular user. So now the ICSF will forward the same invite again to the same part, and it will directly be replying by 100 trying. And again, the same step here, the CSF will go and prompt or invoke the MTAS, asking him whether this user is capable to receive a calls or not. and about, for example, there is no problem in his bills and there is no problems for any restrictions on node guard or whatever. Once it's being done, again, now the invite message will be forwarded directly to the proxy CSF and it will be coming back. And once this is being done, now the proxy will be forwarded to the users, and now 100 trying will be done. Now, once the user received the same invite, which is including the SDB, again, remember, keep this one in right, commonly called SB offer, which is session descriptor or session description. This part actually, it's calling again the media and the codec type. So now the user need to inform this particular user that now I need to answer to you. I need to send you SDB answer, which including my supported codecs as well to start the negotiation. So this message actually, once it's being received the proxy, this message including the supported codecs, the proxy will directly start activating the dedicated bearer for this particular user. So it will be starting communicating with the EBC. Please now start initiating the for example, first it need to, for example, to communicate with the BCRF, with the policy and charge center, just to start make the provisioning. This will be go in details. It will, in general, it will, as summary, it will start the dedicated bureau for this mobile terminating. And it will keep this part, the 183 session in progress, like it will hold it until the dedicated bureau is being activated. Once the dedicated bureau is being activated, the proxy now will start forwarding the same message to following the same sequence which being explained from the CCF to IC. Then again, it will go through the same process until it reaches the proxy for the mobile originating. And now once this message, which is called, which is having the SDB answer, which is having the supported codecs by this users being received the proxy, now the proxy also will start invoking or asking, sorry, requesting the EBC network to start activating the decoder bearer. Once the decoder bearer is being activated and confirmed, now this one will be forwarded to the device, which is 183 ring session progress. And now the UAE or the originating will receive the answer of the supported codecs. So he will compare both originating and terminating codecs, and he will take the common one. For example, let's say that the highest, if for example both supporting super band, for example, whatever highest one, it will be shared by both of them. And the codec usually it's taking the common one. For example, assume that one device supporting only narrowband and the other device supporting all EVS and for example, MR wideband and narrowband and whatever. So it should take the narrowband because the terminating device only supporting the narrowband. So should be something common between both of them. So usually try to take the highest one, but since the highest one, for example, the terminating is narrowband, so it will be narrowband being selected. So once this being done, now it need to send something called BRAC 103 as a response for this 103 message. And this message, is just to simplify it, it should go through the exact same sequence for the same invite, move from here, from UE to proxy, then proxy to CSF, and so on. So it will send until it reaches the user. Then the user again need to acknowledge this message. So we'll send back 200 OK BRAC. Then the user now will send something called update message. Actually, this flow is for the normal flow. Sometimes this is like assuming something called precondition is on. Preconditions means what? Preconditions means that the terminating users, if it's on, the terminating user cannot send 180 ringing until he receives confirmation from the mobile originating that his dedicated bearer or media is being now on or active. So this information will be communicating through this update message. Update message is telling the mobile terminating, yes, now the media is active for mobile originating. Now you can initiate the 180 ringing because now the media is active. So don't worry, you can now reply. So once you receive the update message, he will be responding by 200 OK update as a confirmation for that he received this message. Then directly will be sending 180 ringing. And now that there is a ringing between both devices, you can hear the ringing tune. And once the user pick the call, the user terminating, answer the call, he will send 200 OK save invite, 200 OK invite as a confirmation to the same invite message. Now that I answered the call, I'm waiting also your confirmation that you received this message. So the user will send the final messages called acknowledgement from the UEA to UEB, confirming that now the call is being established and successfully established. So again, this sequence, it might be different if you have, for example, precondition on or you have and so on. There is many different conditions. For example, sometimes you will find directly after receiving the same invite here, he will directly reply 180 ringing. Or sometimes you will see 183 session progress, but there will be no update message. It will be directly sent on 180 ringing. So this is depend on the network deployment or the IMS strategy or the network strategy in general. But this is the main call flow, which the normal one, which is well known by everyone. So now let's move forward for the end-to-end one, which is including the same, but plus the radio as well and EBC. So now we'll go through again the same end-to-end call flow, but now including all the entities. But this is only for the generating side. Terminating will be explained in different session. And first, I will go through the signaling, then I will go through the signaling context for each of the message will being shared here. So assuming the mobile originating was already in idle mode and he would like to initiate a call. So the first process he would like to do, he will send something called RSC connection. He will start establishing his RSC connection. And in this RSC connection, he's sending like something called there's a NAS message called service request, and this service request and the RRC connection request in general, indicating that I would like to do a mobile originating code. I will show you the contents of the RRC connection request, and which is indicating, and also the service request. And this service request NAS message is piggybacked within this message, was called initial UE message. We'll show the contents of this message in the next slide as well. So here the user is indicating, please, I would like to initiate a mobile originating calls. So the MME will receive this now message. So now directly the MME will start initiating the context for this particular user. So it will send them initial context setup request, trying to establish whatever QCI default bearers, which is, for example, let's assume QCI 9 and 5. So it will ask the user now, it will ask the NLB to start preparing the context or activate the context for the default bearers, for example, QCI 9 and 5, because he would like to initiate a call and he is capable of VoLTE call or call over a IMS. So he would like to now establish his dedicated bearers. And every time the user is initiating in the 4G, initiating a request as a service request, he will all the time, the MME will establish both of them as a default bearers, which is by default called, maybe you call it always on for the 4G. So now the users, the next step that will have this security and UE capability information exchange. Then you will have the RS0 configuration message, which including the bearers and the quality of service of both of them, and trying to establish now the DRB, data radio bearer, for this particular user. And this RFC connection setup, including something called signal radio bearer one, and this is including the information which will be used, for example, to start transmitting the subsequent messages, for example, which is the security and the UE capability information. And this will be in general used for NAS messages to transfer RRC messages and NAS messages. So this is also with an RC connection setup. This one, as I mentioned, RC configuration will have the data radio bearer, including PCI 9 and 5, and also the signal radio bearer 2, which is also used to transfer NAS messages as well. So now the init B, once it receives the confirmation from the user, it will initiate initial context setup response. This initial context setup response now telling him it's successfully being activated. But now they maybe need to communicate with the serving gateway to tell them, please now start activating again the paths of the downlink path towards the init B and serving gateway, which is actually includes the information received by the context setup response. This one will just including the init B tunnel endpoint, which would be forwarded from the SMME to serving gateway to now start like creating the tunnel between the serving downlink tunnel between end-to-end tunnel between serving gateway and the init B for the user plane. So the same message will be forwarded from serving gateway to packet gateway to complete the connection, and this is including the update as well about the default bearers which is being activated to the users. So asking them to modify their part and establishing S5, S8, and also the S1 bearer or the tunnel GTP tunnels between the serving gateway and NLB and so on. So this was the part of the initiating calls. We'll go through the messages in the next slide as well. Now the next part, once the user initiated the call, what will happen? Now the user is got the XI 5, right? It's now ready. It's being activated. So now he can initiate the first thing, which is the same invite, which is already discussed, including the SDB offer and the SDB body. Then it will be 100 trying, being response. Then from the terminating side, the proxy will receive the 183 SDB answer. This is coming from mobile terminating. This is including the SDB answer, which is including the supported codecs, for example. Then now the proxy CSF will ask the BCRF to start initiating the dedicated bearer. So through something called AAR, and this is AAR, it stands for Advertising Application Request, and this is including a lot of information, which is, for example, what kind of media is being sent by this particular users. So you would like to start the negotiation, and also the addresses of the UE and so on, and the supported bandwidths and the media type, for example, voice, and most important information is called flow status. Flow status is telling him that still the flow is status is off, means still that the media is not being completed between both of them. Dedicated bearer is not yet being activated for terminating and originating as well. So this is just informing him that the media is still not off. We cannot transfer data now. So it will directly receive a response from the BCRF called the advertising application answer. Then the same message will be forwarded from the BCRF to the BGW, BDN gateway, which is asking the BGW to start provisioning BCC rules. And the BCC rules, like for example, it will translate this information into XI, for example, XI1. So it will ask the BGW to start initiating the dedicated bearer. And this dedicated bearer will include the XI1, MBR, GBR information, and ARP, and all the information to XI information. So now this will be directly responded here for our AIA, which is called a re-authentication answer, and the first one re-authentication request. Then directly it will send create bearer request from backend gateway or BDN gateway to the serving gateway, asking them now please start initiating the quality of service. And this is the EBI, and this is my tunnel endpoint. Now he would like to create a new tunnel endpoint, right, for the XI1. So it's telling the my tunnel endpoint for the S5, S8 for the packet gateway. This is my tunnel endpoint ID. So, and this is the quality of service I would like to create. So it will send the same message from the serving gateway to MME, and this one will include, it will add on top of it the serving gateway tunnel endpoint. Then it will MME will take the same information which is being sent here. It will forward again to the node B, asking him please now start activating the dedicated bearer context request. Even you will find in the traces Wireshark that this called ERAS request, for example, plus the name, it will be between brackets that calling activate dedicated bearer request. Then the node B will send the same information, which is including quality of service for XI1 through the RR0 configuration, including the DRB information for XI1 to the UE. Then the UE will, once replied, he will gain coming back ERAP setup response, then create bearer response, and so on. This is acknowledging the connection. Once it's being completed here, this means the dedicated bearer already being activated. So once the dedicated bearer is being activated and it's being confirmed here for the backend gateway, now the PC can now, or the PCSF can now send 183 session progress directly to the users because it's confirmed that the gear is being activated. It will send them this to the users. Now the users wants, because he already activated the gear, he can now reply with the BRAC as a response for 183 response. Then again, as we discussed, the side of proxy will receive a 200 OK from the terminating side. Then now the originating will again sending update message telling them, okay, because precondition was on, telling them now my media is on and I have already activated the data bearer, so you can now initiate the call, or that you can now send 180 ring. So it will send a confirmation 200 OK update. I received your message. Now I will send ringing to you. So it will send before sending the ringing, you will, because this one already received 200 OK update, the proxy CSF from the terminating side. This is for the originating, received already from the terminating 200 OK update. So he need to, and he received a confirmation from the originating that the media is being on, right, or activated, the bearer. So he need to update the BCRF that now the flow status is on. Both originating and terminating has the bearer activated. So now the flow status changed from off to on, so it will send these messages just as a confirmation. For the media, now it's being on, so now we can start having a flow or traffic flow between both of them. So directly now, the terminating will send 200 OK message. This one will be sent once it's being the serving BCSCF will send to the UE the 200 OK as a response for this update message. Now the terminating will be sending for the BCSF of the originating the 180 ringing and 200 OK invite. 180 ringing first, it will be sent. Then after 180 ringing being sent, it will send 200 OK invite that I confirm, I answered the call. One OK invite come after the 180 ringing once the user pick the call. So the terminating pick the call. So you'll send after the 180 ringing, you'll send 100 OK as invite for the same invite, confirming. Once the user confirming that he sees the message, he will send now acknowledgement message as you can see here, confirming the call is being established. Now let's go through the details of the messages. We'll take it one by one. First, I will split this end-to-end flow. I will take first the initiate VoLTE call and go message by message. Then we go through the next part, which is will be more important about the information for the save invite and so on. So let's move forward. And before going forward, that as you can see that now just here confirming that RTB is now carrying and the queue is on, and now the traffic is being flown. So now let's move forward. So as you can see here, first I take only the part related to the initiate VoLTE call, which you already explained it, right? So I would like to take one by one, but this is how you will see the messages from the Wireshark. For example, here from Wireshark, he see all the S1 AB and tell the serving gateway. So he see the initial UE message. And as you can see, the service request was coming from the UE is piggybacked with the initial UE message. Piggybacked because this was NAS message. So it's just sending through the initial UE message. That's why it's called service request. Then you have the initial context setup request. This is also including the UE capability information and asking for the UE capability information. For example, for this one, UE initial context setup request, which is this message. Then you will have the initial context setup response here, as you can see. Then after the modify EBS peer will be sent from the MME to the serving gateway. And here we have to, because we have to exercise, for example, 8 and 5. So one will be for 8 and one will be for 5. So now let's go through the first message. For example, this, as you can see here, the first message, for example, the RSC connection request. I just quoted from the 3GPP what kind of information you will have. If you zoom in here, let's move here. This is both RSC connection request and setup. The RSC connection request, as you can see, it will having the STMZ. This is the most important, and also this will be the calls called voice call V1280. And the RRC connection setup, which second one, will include information about the SRB1. So let me show you what we'll have in this information, especially for the second one, which is RRC connection. As we highlighted here, the RRC connection setup was coming here. It's coming to establish the SRB1, which is a B1 will be used to transfer the subsequent RRC messages. For example, the RRC connection setup complete, and also the NAS messages, for example, the service request and so on. So as you can see here, for example, this message is called RRC connection setup. Under this part, you will find SRB to add to mid list. Then you'll find the SRB identity, which is one here. Then we'll find all the related parameters for that part. For example, this is acknowledgement mode, use acknowledge mode. And this is the parameters, for example, the T-ball retransmission for the uplink, and also for downlink, this is a retransmission. Then we go through, you'll find many other information related to the logic and the channels, and also you'll find another information, all the other information, which is very important. For example, if you open this one, we'll have the BA power, what is the power, and many others. For example, if you look into the antenna, it will tell you what is the transmission mode. You use here, for example, transmission mode. So this is like sample from the content of RC connection setup. So now let's move to the next messages. So the next message, we need to explore what we have inside the initial UE message. So let's go. So as you can see, the initial UE message here, including the service request, right? All the service requests, and this is usually include this information as you can see here. First part here, that having 6 items. It sometimes can be more, but this is the most common. For example, S1A APID. This is common. Sorry, this is unique for this particular user, and it will be like it retain all over the call until the user go idle mode. It can be even used for filtering in Wireshark. It will filter all the SAP messages for this particular user. Then here, this TAI, it will include all the information about the user location, tracking area update, MCC, MNC, and the CGI as well. This one will having the cell ID. And here we're having the RSC establishment calls, which we showed MO voice, confirming that this is MO voice and the STMZ. And both this, if you remember, it was already included within the RSC connection request. Okay, moving forward, next message actually will be the initial context setup request. And this is will mainly include many information, but the most important for us is which ERAB you would like to set up. So here it will include the default peers, key size 9, for example, or 8, or 6, or 7, and key size 5 as well, which will be used for IMS. Asking the NLP, please now start initiating the context and the DRB, the data read bureau for this particular user. So now after that part, this part already will having the same information, so I'll not cover it again. I'll jump it directly to the initial context setup response, and this is very important as well. This one will be covering first, telling them this is a successful outcome, it's being successful, and within this part you will find something called ERAB two items, right? For example, here, which is ERAB ID 5, and also we have ERAB ID 6. For example, both of them will be sent in that part. If you open the other one as well, and it will tell them this is my tunnel endpoint for ERAB ID 5. This is my tunnel endpoint for the inode B. To take this part and forward directly to the modify EB and within the modify EBS request. And you can see here we have two modify EBS, one for example, ERAB ID 5 and one for ERAB ID, for example, 6, which is one for the XI 6 or 8 or and one for the other T3I, which is XI 5. So this is information about the initial setup response. Now moving forward to the modify EBS peerer, as you can see, we here this one will having first information about the user location, right, with cell ID and so on, and tracking area update, blah blah, and all these kind of things. Then this is the EBI, which is 5. Also, it will have another one for the another QCI as we mentioned. Then it will forward tell them that okay, this one inode B GTPU interface. This is the tunnel end point for the inode B to now start having the tunnel between the MME and the serving gateway and the inode B. So it's telling him what was the tunnel endpoint from the inode B side as well, and this information will be forwarded again to the packet gateway. And once it's being done, it will be responded here and so on. So now let's move to the next part, which is related to the end-to-end signaling for the contents from the starting from the invite message. So as you can see here from the same invite message here, this is the content on the right side here. First, as you can see here in the top right, this is actually the same invite will having a two piece of information. The first one, which is the SIP header or the SIP part, which is including the information about the what is the device, terminating number IB, originating number IB. We'll go through the details here now. And the second one, which is called SDB part, session description protocol. This is we'll go through in details about that part. So the first part, it's about the SIP part, which we'll be having here. If you go this part, you will find first here in the top right here the request line. This is telling them this is my number and this is my network at this particular network, and this is for the terminating actually. I'm trying to invite this particular number. So this is the URI of the terminating number, which is including the number at IMS, for example, mobile network in Egypt or whatever indicating here. Then you will have this message header, right? The message header here will call via first. The via telling him that this is coming through me through the originating. So this is my IP, right? So this is my IP for the mobile originating call. Then you will have this maximum forward already explained. This is including how many hops you can go through. For example, you will find forward first to proxy, then SCF and so on. Then you have this route information. This route information include information about the IP of the proxy CSCF and serving CSCF and name and information about for the mobile originating call. Then you will go through this contact information. It's telling him first of all my contact number from mobile originating is this my contact number, for example 987654321, and some information about the port number and so on, and then telling him that yes, I'm stating that I'm supporting the MTAL or MTAS in general. Then the other information is important as well. Here it's called here it's saying allow. It's telling him that I'm supporting all these kind of save messages because sometimes there might be a problem in the save messages capability. So here it's telling him I'm supporting all these sub messages, so I can initiate or receive or whatever for this kind of save messages. Then here it's stating that I'm supporting precondition as well, and 100 release. This is related to 183 as well. Just support precondition, and stating that's a support precondition. Then the last part here is called B-access network information. This is having important information about the serving cell. For example, it's telling him I'm coming, I'm initiating the call in FDD. It can be TDD, it can be NR, for example. In the voice NR part, will be covering this part. And this is my cell ID as well. So this is the SIP, first part of the SIP, which is the SIP part. The second part now we'll go through it. It's the B part, which is including the codecs. And this is very important because it will look like complicating in the beginning. So actually moving to the SDP part now, within the SIP invite, as you mentioned, we'll have SIP part where you explain, and you have the SIP message body where we're including this SDP part. Now let's move and zoom in and see what we have. As I mentioned, it first indicates that, for example, the media is voice, for example, as you can see here. It's telling him the voice is voice over IP. And here is telling him I'm the owner. Here you can see usually the messages will not be coming like this. You'll find it as this between practices, for example, O or V or S or A, and they'll explain this is the name of these sessions. The Wireshark translated like this. For example, this is telling him the the session description protocol version. The version of this DB is version 0. It's not that really important information. Then you will have this session ID. This is my IB network. For example, this IN received indication to IB network, and this is I'm using IB version 6, and this is my IP for the originating. And the session name, for example, I'm calling this mobile terminating or UEB, and this is called voice over IP, which is SSYB. I'm writing this by mistake. Anything you see hash, this is my writing here, just to explain it. Then you'll have this kind of C here, C indication for connection information. And this is including the IP address of the mobile originating number. And it's asking the network, whenever you send a feedback or a reply, please send it at this particular IP version 6, and this is my IP. Then you will have the media description, and this is the most important. Actually, this is the most important part, that is telling them I'm going to make a media call audio, right? This will be a voice call, and I'm supporting 4 codecs. You can see RTB, AVB. This is related to the codecs. I'm supporting 4 codecs: 112, 116, 115, 118. Then it will split each one of those below here. I will explain to you now. Now it's stating first, audio means voice call, and this codecs means I'm supporting 4 different codecs. Now it will start splitting here. As you can see, first one, 112, you will find something called media attribute. Sometimes you'll find as A only. A means attribute, okay? So it's telling them that RTB map 112, for this 112, RTB 112, it's related to EVS, and this is the sampling rate, which is 16,000. So this is the codec type for this 112. It's EVS and 16,000, right? So this is the first type. Usually in the Wireshark, you'll find that you can open these messages and you'll get this information below it, but you can directly even read it from here. For example, this RT map 112 is equivalent to this one. EVS means this is your type, and this means your sampling rate. So EVS 16,000. Then here, this is media, something called again under the same message, media A, also attribute called FM. This called RTB map. FMTB 112 as well. So still you are speaking about the same codec. This just telling them that I'm supporting the mode change capability. I can change my capability, for example, for the codec, and I added the reference of 3GPP in the bottom right here. You can get that more details about this part. Then it will again go through again one by one. For example, 116, it will tell him see here attributes A. 116 AMR wideband 16,000, as you can see here. Then 115 again here AMR wideband 60,000 as well. Then the last one, for example, 118, I'm supporting AMR 8,000. Then it will have some information about the channel bandwidth. The channel bandwidth is 50 kilobyte, as you can see here, and this is just indicating beat time, attribute beat time, that the packet time is 20 millisecond and the maximum is 240 millisecond. And the most important is called A, which attributes inactive, saying that the media is still not inactive. I don't have yet a dedicated bureau, so take care of that part. And here is saying that the current quality of service local none means I don't have any quality of service yet being initiated or established, and local for the serving, and whenever it's removed, this means it's terminating calls. Then here is saying that the quality equal DES, quality of service mandatory local send and receive, just stating that I'm mandatory. I'm telling you that I want to send and receive data. So this is just telling their or capability to the network. So this is the SDP part. It's very important to understand it. And here I just refer to the RFC for this particular part related to the capability of the media change, if you would like to refer to the details about the RFC number for the point which I'm mentioning here. Now let's move to the next message. Next message is actually it's about 183 SDP answer. First, the SPC will directly reply with SIP or the proxy CF will reply directly to CF while not trying. It's just telling them don't send more any invite request. Then here, this is very important. They will receive the answer from the terminating calls, right? Which is 183 session progress, right? This is actually including the SDP answer. The terminating side will tell you about his supported codecs. For example, here he mentioned he's supporting coding 107 and 101, as you can see here. So 10107, for example, is indicating that I'm supporting AMR. Let me zoom here quickly. It's saying I'm supporting AMR wideband 60,000, and 101 is saying that this is that related to telephone number. So probably this will be the codec which would be both between both of them, because this is like the common between both of them. And here it's also confirming that I'm supporting the precondition as well. So this is the SDB body for that part. Now what will happen? The Once the proxy receive this 183, it will start initiating the quality of service, right? This AAR, as we mentioned before, it's including a lot of information. The first, and you can find this information in 3GPP 29.214, and the first part called service info status, just telling them that what is the current status of the media. And here it's just telling the media type. For example, the media type is audio, it's telling the BC, and this is the maximum supporting downlink and band requested bandwidth for downlink and uplink. I just quoted the downlink, but uplink was exactly the same. For example, he's mentioned here 49,000, just to tell him the information which he's going to make a BCC lookup to start initiating. Based on this information, he will start setting his BCC rules for the quality of service, for example, QCI1. And here is telling the flow status AVB. This one actually in this message, it should be off. But once you receive and the DKB is being activated for the originating, the last one here, AR, it will be now it's being enabled. So this will become at the end here. So this is the information about the AR. Now the next one, actually, the terminating side will generate this AR after receiving the 183, right? This is just a reminder for that part. Yes. So now moving for the next part, which is AA, just this is referring that this is successful. The diameter is being successful. I have received it and I have received successfully, just replying as a successful. Moving forward, actually, for the dedicated, once that this information moved from here to there, this exactly same information will be forwarded from BCRF to BGW, asking the BGW, now this is the BC rules. I would like you to start creating a QCI1 or dedicated bearer, or to create a bearer for the quality of service one, QCI1. So this create bearer request, as you can see here, it will have a lot of information. For example, the first one is EBI, telling him my EBI is 6, and this is the quality of service. And also it's telling here, this is the QCI1, and this is the bitrate for uplink and downlink, maximum bitrate and guaranteed bitrate, GBR and MBR for this QCI1. And also telling him my tunnel endpoint, which is S5, S8, is this. So it's telling the serving gateway as its tunnel endpoint. Then again, the create bearer request will be sent from the serving gateway to the MME. Then MME will send the inode B, the ERAP setup request message. And the ERAP setup request message will just include the information about the XUI1, which is already we're including in the create bearer request. And again, this one will be forwarded from the MME to the UE, which is again including the information again about the EBS bearer identity, for example, what kind of XI1 information, for example, those for 7, and all the information about the data ready bearer to start establishing this part. And once this part is being done, now the remaining will be continue for the messages. It will reply the confirmation here once it's being received from the BGW. Sorry. Once it's being the give is being established actually. So in between this is might be sent as well, but the mobile originating will receive now the 183 session progress, and we reply with BRAC. Then the terminating side will reply with 200 OK BRAC, will coming through the serving SPC or BCS. Usually they call BCSF as SPC. So it will forward 200 OK BRAC, and because precondition is on, so the other side will not send ringing until he receives the update message. So UE will send the update message as we explained. Once you send the update message, so now he will say the BCSF will receive 200 OK update for that part, but first it will change the status flow from off to on, informing the BCRF that both sides now have the been activated. And it will the BCSF now, once it's informed the BCRF, it will further this 200 OK to this particular user, and directly the terminating side will send 180 ringing, telling him now I'll start ringing, and after it will send 200 OK invite. 200 OK invite means that he already picked the call, he answered the call. And once he send the answer the call, he will wait a response from the UE, which is acknowledgement for the 200 OK. And now this means the flow is being established between both sides, which is KSI1 is being established. So that's it for today's session. Sorry for going very fast because I was trying to make it much less time, but it takes again more than 50 minutes. So I hope if you like the contents to click like and share it with your friends, and please spread the word. And thank you, and see you next session. Thank you very much. Bye bye.